So the answers to page 59 for question 14. Once again, it's lifted straight from a learning outcome. So see your learning outcome note 36. 15, 16 calculations. 16, just note though, with double the speed, you should notice that the answer you get for the kinetic energy is 4 times as big. 17 starts with a calculation, but for 17b, it says name the 2 sources of this kinetic energy. So reading the question carefully, we've got a cyclist that's pedalling down a slope. And when it talks about sources of kinetic energy, it really means what type of energy did that come from. So what was the energy transfer? In this case, there's 2 things. If you rolled down a hill, even without any pedalling, then you would still gain kinetic energy. And that would be an example of gravitational potential that we were studying earlier, because that is the energy something has simply by being up high. But the other one is this idea of pedalling. Well, ultimately, where does that energy come from? It is kinetic when you're turning the actual pedals, but ultimately that comes from your body, from your food stores in your body, converting that in your muscles. And your food stores are chemical energy. So we have gravitational potential and chemical energy are the answers for 17b. For 18, once again, it's an approximate one, so it's probably worthwhile going through an acceptable answer, but not the only possible answer. So first of all, we want to get the idea, approximate value for the kinetic energy of an Olympic 100-metre sprinter. And we know the race is about 10 seconds. So we can do a quick calculation of, we're given a distance of 100 metres and a time of 10 seconds. And from that we can get an average speed. Okay, the instantaneous speed will probably be a bit different. But we can get an average speed, the distance over time. So they're going about 10 metres per second on average. Now given the start from 0, it probably means at times they'll be going at 12 metres per second, a bit faster. But we get the idea overall. So we've now got an average speed. Now we want to try and estimate a mass. So for a sprinter, you're talking about somebody fairly lean but muscly, so maybe 80, maybe outside 100 kilograms, but reasonable mass involved. And now we're ready to do our kinetic energy calculation. Now in terms of pure problem solving, you may have got to the EK equals a half mv squared and then realised I don't have anything, and that then would lead you to the distance and time that you've got, and you're going to calculate a speed. And we're using the average speed as the speed at any particular point during the journey here. So EK is a half times 80 times 10 squared, and that gives us 4,000 joules of kinetic energy. And the rest of the calculations, don't forget to check your answers. Don't forget to show your working as well. List your variables, write your formula, show your substitution. All the good practice that you've established.